Hi, hello everyone. My name is Anuj. I'm from India. So I'll be talking about visualizing the world of competitive programming. Uh, so it's been about 5 years since I first wrote my first Python code, and I'm a mathematics major from Indian Institute of Technology, India. I worked with American Express for a year as a big data analyst, and I am very passionate about speed cubing. So that is like solving we play around with puzzles like the Rubik's Cube, and it takes about 10 to 15 seconds to solve. So yeah. So a little bit about the talk. The talk is going to be divided into two parts where I'll be talking about the entire process or the way the project was structured, because nowadays we are focusing on projects where it involves scraping a website, gathering a data set on our own, and then performing an analysis for an outcome. So that is what the talk is about, and I'll be talking about one particular project which is competitive programming. So has anyone worked with competitive programming or any competitive programmers here? Just for context. Okay, great. So I'll just give you a brief overview about competitive programming. Competitive programming is more about a fixed objective and achieving the objective with specific constraints, like the number of iterations can be infinite, but the program has to execute in a specific amount of time, let's say like 1 second or 3 seconds, depending on the programming language you're using. So the website I have used is called codeforces.com. It is a online programming contest where you have questions, and this is like the structure of the website. You can use any language you want. There are different types of questions, like let's say dynamic programming, greedy algorithms, just basic math or implementation. And it also has a lot of people solving the questions. So for example, if you can see, it's 884 ABCDEF. So that is one contest which is conducted globally, and that is the number of people who are able to solve the questions. So this is the website I have used to scrape. So the data set is basically programs people have written. So there are so these are about, So these are about 500,000 programs which people have written in about 16 different languages: Java, C, C++, Python, and everything. And there are the codes were written for about 3,500 plus questions, and like for example, you can see different type of questions here: implementation, dynamic programming, greedy, brute force, data structures. So the total number of type of questions is 50 to 60, and submissions from 30 plus countries. So this is a data set we have used for the entire analysis, and I have performed a few visualizations, and I'll also give you the actual objective of the entire project. So the project started off with trying to distinguish the way beginners code in Python to the way expert programmers or experienced programmers write code. So that was the objective of the project, and I have created a few visualizations. So the first and foremost is the number of years the person has been coding till now. So this is basically the chart. If you can see, the biggest chunk of the chart is less than or equal to 2 years. So it's kind of, we can infer that the people who come onto the platform to learn competitive programming usually stick for about 2 years, and it goes on, like the harder it gets. So it's like there are very less number of people who stick till like 6 or 7 years, and they are mostly the chunk which you can call experienced programmers or expert programmers. So this is a complex visualization. So this is basically a language used for solving the problem versus the type of the problem solved. So this is like implementation, dynamic programming, greedy, math, and brute force. So if you can see, usually Python is not the best language to use to solve questions in competitive programming. So it is usually, C and C++ are usually used to solve questions in competitive programming, and that is one area where Python is still working on. So this is just like a check for our data set. And then this is the rating of a user. So every user has a particular rating based on the number of questions he's able to solve in a contest. So this is simply the number of competitors who were able to solve a question versus the rating of the question which was solved. Yes. So this is more like if a question is difficult, then we can only see people with a higher rating solving them. This is towards the end. So people with rating of 2,500 to 3,000 are the people who solve the questions which are very tough. Right, so this is like an obvious kind of observation. And the evolution of language over years, I've only compared 3 languages: Python, Java, and C++. So as you can see, C++ is used by about 80% of the programmers on the platform, and Python and Java are about 10 to 15%. Now this is the average rating of one particular category of questions. Let's say we pick up dynamic programming. So the average rating of users solving a particular type of question has been decreasing over the years, which goes on to say that more and more people are trying to solve difficult questions, and the questions are becoming, I mean, I don't think we can say that the questions are easier now. We can say that more people are trying to solve the questions in different areas like dynamic programming. So this is simply trying to see which categories can be ranked as the most difficult categories. So a few are fast Fourier transform, flows are one of the most difficult questions in competitive programming. So this is simply the average rating of all the users who were able to solve this particular type of question. Yes, so this is kind of my favorite. So this is the number of lines of Python, and this visualization is specific only to Python, obviously. This is the number of lines of code a user has used against his rating. So this goes on to say that experienced programmers tend to get things done in less number of lines of code compared to people who are starting up with Python. So it's like, if anyone is aware of list comprehensions, that basically takes 1 line compared to a for loop which is written in at least 3 or 4 lines, right? So that is kind of what this observation is. And a few demographics. The platform has the highest number of users from India and China, Russia, Bangladesh, and Egypt. But the highest rating, so that the average rating is the average of the top 100 users from a country. So that is how it ranks. So basically this analysis has been performed on a particular data set I scraped myself. So as I told you, this is 500,000 randomly sampled codes. So the entire database was about 21 million codes on the platform. So that is a huge data set, and I only had to do the analysis on my laptop. So I randomly sampled them to obtain a 500,000 sample of programs, and then the analysis was performed there. So I'll just walk you through briefly over the web scraping process I've used and how the pipeline was constructed, like which website, how do you choose a website, or even after you choose your website, how do you actually target the right elements. So has anyone used web scraping before in their job, in anything? Yeah, a couple of hands. So web scraping is simply obtaining meaningful information from any website you would want, be it an airline's website, or e-commerce website, or a taxi aggregator. So everyone needs to, like, let's say, even if I want to see or even if I want to track a price of some commodity on Amazon, it would make my life easier to just write a scraper which alerts me, like gives me an alert of the price every day, right? So it is a very simple web scraper, and that's the most basic implementation. So if you can see, so the common libraries which are usually used in Python for web scraping are called Beautiful Soup, Scrapy, and Requests. So there is another library called Selenium, which is a browser automation tool. It's not usually used for web scraping, but that's kind of a hack to scrape websites which have dynamic content loaded. We'll talk about that as well. So this is kind of the entire pipeline which, so the objective was to distinguish the novice programmers versus the experienced programmers, and then choosing the right website. So this is what, so there are multiple websites which have competitive programming, like CodeChef, Codeforces, Topcoder, and stuff like that. But Codeforces has every program written by a user publicly available. So every other websites do not have the other users' programs publicly available. So this was the website I could choose, and you should also try to like just hit the website multiple times and see. So for example, a few websites are not really friendly. So they have a robots.txt file which says that you're not allowed to scrape this particular section of the website. So you should be checking these prior to your scraping exercise. Or a few websites have limits limits like, let's say, they only allow 40 to 50 requests a minute. So if you're planning to scrape 1,000,000 pages, it's going to take you ages, right? So unless you use proxies to use multi-processing. So these are a few parameters you need to see when you are trying to choose a website. How friendly is the website or stuff like that. Read reviews online. And then you have to break it down to a very simple structure. For example, here there are components like a user rating, the place from where the user is, how many years. So these are all different pages, right? You don't get all the information in one API call or one user request. So you need to get them differently, separately, right? So let's say you first access a user's rating, then you see all the questions he has solved, and then you try to figure out what is the category of the question being referred to in this context. So these are three different, I would say, pieces of information you need to gather and then put them together back. Also, the scrape feedback iterate would mean that, for example, let's say you come across a section which you're being blocked. Let's say you've scraped continuously for a few hours, and then you see a 403 error from the website saying that you're not allowed to scrape this site anymore. So you either have to see if you just got a temporary block, or you need to see if it's just your component you're trying to fetch, or just try to find a workaround or something like that. So yeah, scrape, feedback, and iterate, and then putting the pieces together, you now have a meaningful, you have meaningful information now. Let's say a user, all his questions, and for every question, the program he has written, the time it has taken to execute, the language he has written in. So all this metadata is now connected after you break it down, scrape it separately, and then put it together. So now you have the data you need to make the visualizations or the analysis you would like to do. For example, this data set can be used to predict things like, let's say, okay, you have 10 lines of Python. Let's say you need to see if any of the combination of lines can be replaced by a function inbuilt in some library. Let's say you are using a sorting function, which is already there in Python, right? It's just a sort parenthesis, right? So if someone is writing a code for bubble sort or some sorting algorithm, your code should be able to predict and mark the chunk of code which is doing that. So for this data set would be an excellent training set for those kind of problems, right? So you can go on to build visualizations and predictions. So yeah. So a small tip, and this is something which I find very useful when I'm doing web scraping. So this is basically simply using multi-processing, and this is like, so basically this is the 3 lines of code which you need to know and add to make your script function parallelly. So this is simply a library called multiprocessing, and this is so you just have a list of URLs which you need to scrape, and then you have a function which makes a browser request and gets you the information you require. So this is simply the function and the list of URLs, and this is how it works. So this divides it into 10 different processes, but it depends on the computer or the server you are using to scrape, because there is something called a global lock, or I don't remember, GIL, which is a bad thing about Python again. But yes, this is a tip, this is a tool, this is a piece of code which actually helped me a lot when I was doing any scraping exercise. Oh, also before we move on to the next slide, I mean, there are a few practices which we usually call ethical practices, where we do not overload the servers. Like I could have always made, let's say, millions of requests a second by using GPUs or servers, but that actually damages the website in a few cases. So you should not be very aggressive. Try to keep the limits very low so that the functionality of the site is not disturbed. And yes, I mean, I usually use a few data structures like queues and stacks. They are very basic data structures to organize your scraping exercise, so that, like if you use an internet connection in the between, you have a backup and stuff like that. But yes, do not aggressively hit the servers. So also the one thing which was really handy was using NoSQL databases. Like I use MongoDB to store all the data I've scraped, because when I'm scraping a data, I don't know what I might be needing in the future. Let's say I'm just writing a scraper to get all the user ratings. But now I find out, okay, if I had the country of the user as well, it would have been it would have made my analysis better. So in that case, if you just have all the data dumped in a NoSQL database, you don't need to organize a structure, right? So for those who don't know about NoSQL databases, they do not have a predefined schema. Like you have to have an ID, then a user age, and then a username. You can just dump any type of information into the database without worrying about the structure. Because scraping needs a dynamic, like for example, if you're breaking it down, all the 3 sets wouldn't have the same schema, right? So if you need SQL databases, you'll have to make 3 different databases and then join them again. So it's a big, I mean, I find this better. So I usually use Mongo to store all the information. I mean, I just dump everything. And then after I have all my data, I just try to clean the data and make sense of, I mean, I just try to extract all the features I require. Yeah, so I think that is it from my side. I'll be really happy to take a few questions if we have some time. Thank you.
Yes, do you have time for questions?
Yeah, sure.
Yeah. So, how do you find out how fast can you scrape? I mean, how friendly for scraping sites are? Because for different sites, the limits are.
So his question is, how do you find out how friendly a website is for scraping? Like, how many requests can you make in a minute? So it's usually trial and error. So like, let's say you just keep the crawler running, and if you're blocked after a minute or a few minutes, so you do it again. Let's say you repeat the exercise multiple times and just see. So I usually use 50 requests a minute, which is kind of safe and not very slow. But it depends on the website. For Codeforces, there was no limit. But I actually mailed them for permissions to scrape the website so that there's no issue. But yeah, so yeah, it just depends on the website. But even if you don't have a limit, you can just keep a flexible limit.
Any other question?
Okay, I think that's it. Okay, sorry. Yeah, thank you so much. Thank you.
Thank you.